welcome you all in this presentation related with the subject fundamentals of surface engineering. And you know that we are talking about one approach where in a layer of the required material is deposited onto the surface of the substrate, so that the required improvement in tribological life of the component can be achieved. And under this category we have talked about the weld surfacing and laser cladding kind of processes, wherein the melting of the material to be deposited and the substrate as well is ensured in order to have the good metallurgical compatibility between the two materials, so that a very coherent adherent surface is formed and there is no issue of the bond strength. But there is another category of the processes where in a layer of the material is deposited using the thermal spray processes, and in this case the melting of the substrate is not ensured. In some of the cases the melting takes place, but that melting is very limited. That is why the dilution is not an issue in this group of the processes. So what is the basic principle of the process and how does it work, and how do we get the layer of the required material onto the surface of the substrate for the property enhancement or for enhancing the tribological life of the component. So this group of the processes are called thermal spray processes. Thermal spray processes means we have to use the heat in one or other form which can come from the combustion of the fuel oxygen mixture, and this happens especially in case of the flame spray processes, high velocity oxy fuel spray process, and detonation gun spray process. The heat can also be used from the plasma which is generated. So the heat of the plasma which is obtained through by establishing the suitable arc between the electrode and the nozzle. So this plasma is used for having the required heat for thermal spray process, and the process which uses the plasma for a spray purpose is accordingly termed as the plasma spray process. In some of the cases even the heat of the electric arc is used for spraying the material onto the substrate, and they are called arc spray processes. And then there is one more category wherein the energy in the suitable form can be used for development of the coatings onto the surface of the substrate. But these are the three most common sources of the heat which are used for thermal spraying of the material onto the substrate. This is like flame, plasma, and the arc. So how does this process work in here? Like we have to use one basically the processing chamber, that we can say, where the suitable source of heat is utilized in form of the flame, plasma, or arc, and in this the process chamber we have to feed the material to be deposited. So we have to supply the feed stock, which is basically material to be deposited onto the surface of the substrate. At the same time, sometimes we apply also the compressed gas or air, so that the required velocity to the heated particles can be given. So this the feedstock mostly is used in form of powders, but it can also be used in form of wires. So, the feedstock is fed into the process chamber where we have heat coming from the flame or the plasma or the arc, and here the feedstock is heated. So, the according to the source of the heat, the temperature rise may vary from like say 500 to 3000 or more for the flame or the for flame based processes, but for plasma and arc it may be in range of like say 5000 to even 15,000 degrees centigrade. So, significant rise in temperature takes place in the heating chamber where the feedstock material will be heated, and under the effect of this heat the feedstock will be subjected to either complete melting. It can occur on only the like the partial melting, means either complete melting or the partial melting of the feedstock. In complete melting, entire powder particle will be brought to the molten state, while in case of the partial melting only skin of the powder particles will be reaching to the molten state. And there is one more possibility that heat can cause just the thermal softening of the powder particles. So, there is no melting, but only the softening of the entire particle remains in the solid state, only the softening of the powder particles takes place. And once this happens, then these particles will be accelerated towards the surface of the substrate. So, like this is the heating chamber through which the flame will be coming out or arc will be coming out or the plasma gas itself, and these will be the carrier for the powder particles, and through this the flame or the arc or the plasma, these powder particles either in molten state or semi molten state or in a plasticized or thermal softened state, they will be coming out, and these are accelerated. These particles are accelerated towards the substrate. So, these particles will be accelerated towards the substrate and they will impinge the substrate almost at 90 degree. So, impingement of these particles either in molten condition, semi molten condition or in the thermally softened condition, they will be impinging with the surface of the substrate. So, depending upon the kinetic energy of these particles at the time of the impingement with the substrate, the completely molten particles which were spherical before impingement, they will get flattened after the impingement, and this will be leading to this flattening will be leading to the formation of one typical disc shape geometry. And since the powder these particles are very small in size, and when they impinge with the surface of the substrate which is much large in size, so these the heat of these particles is extracted very quickly. So, the molten particles are subjected to the rapid cooling. Because of this rapid cooling, wherever the impingement of the particles takes place, there the molten particle will get solidified with the surface of the substrate, and this is how each particle will be impinging with the surface of the substrate or already deposited material layer, and this kind of the disc shape structure which is formed after the impingement of the molten particle with the surface of the substrate is called splat. So, basically in the thermal spraying, the molten or the semi molten particles which are being accelerated towards the substrate, they will be impinging with the surface of the substrate and then they will be getting flattened. So, this is how in this case the heating is primarily taking place of these particles and the metal is being deposited in form of the unit pieces in form of splats. So, each splat is basically a lump or the piece of the material which is being applied over the surface of the substrate, and when the continuous splat deposition over the surface of the substrate will be leading to the formation of a continuous layer of the material which is being applied on the surface of the substrate, and this takes the shape of the coating. So, this is how the process works in the material, like the raw material is fed in the process chamber and then it is accelerated. So, heating, then acceleration and then finally impingement of these particles with the surface of the substrate. So, these are the key things. So, up to what temperature, means what is the temperature up to which the heating is taking place, and how long the high temperature is maintained, how long the particles are exposed, stock material is exposed to the high temperature. So, the exposure duration of the feedstock material at a high temperature, these are the two crucial things which will be determining the quality of the coating material being applied. So, about this we will be talking in detail in the subsequent portions related with this presentation. So, now if we see since the different heating source will be offering the different temperatures, like in case of the flame spread coatings it is 3000 or 5000 to 10,000 degrees centigrade in arc processes, arc based processes, and the plasma based processes like 10,000 to the 15,000 degrees centigrade, and they are accelerated to attain the maximum velocities as per the process. The acceleration magnitude will be varying significantly, and accordingly the particle velocity, there are two aspects. One is the velocity at which hot flue gases will be moving, and the another one the velocity at which the particles will be moving within the flame. Normally the velocity of the flame or velocity of the hot gases or the plasma is higher than the velocity of the particles which will be with which it will be moving, and finally impinging will be taking place with the surface of the substrate. So, for this only, if you have to see, this is what the scheme is like. The material may be used in form of the rods, in form of wires, or in form of powders, and this is subsequently heated using the suitable source of the heat. This source of heat may be in form of arc or the flame or the plasma, and then it is accelerated towards the surface of the substrate, and once the accelerated these high velocity particles are impinging with the surface of the substrate, they will be getting flattened like this and forming the splats, and the splats will be depositing one over the other, and when this process continues after the solidification, the coating is formed on the surface of the substrate, but these coatings or the thermal spread coatings are not free from the defects. There are various issues related with these coatings, but this we can say one typically flame spread coating of the nickel chromium based alloy system onto the surface of the steel. This shows that very sound and free from the defects, but there can be defects, other defects like the cracks in the coating as per the kind of the materials, and the thermal expansion and contraction behavior of the material as well as the of the substrate material as well as the coating, and there can be the pores and other discontinuities present on the surface or within the surface of the coatings. So, if we have to understand what are the kind of the discontinuities which can be there in the flame spread or the thermal spread coatings, so there are various things that we can see here, like if this is the surface of the substrate. So, when the molten particle impinges with the surface of the substrate, it will be getting flattened, leading to the disc shape formation, and similarly the number of such kind of the splats will be depositing over the surface of the substrate. So, one layer is deposited, then another layer of the splat will be coming and will be getting deposited on the already deposited layer of the material. But since the molten metal particle will be at a higher temperature and it will be interacting with the other gases which are present all around the molten metal particle or the partially melted particles. So, there can be the interaction between the gases and the metal material of the feedstock, and that will be leading to the formation of the undesirable chemical reactions resulting in the inclusions within the coatings. So, these inclusions will be there in these coatings if the too much of the interactions between the gases and the feedstock material is taking place, and this is possible only when the high temperature is retained for longer period, like the particle is moving slowly through the heat source and getting lot of time for interaction of the feedstock material with the gases, and this will be leading to the formation of the inclusions. So, these inclusions may be present here and there. There is also a possibility if the impingement velocity or the kinetic energy of the particles at the time of impingement is not very high, then it will be leading to some of the gaps being left unfilled. So, these gaps will be there in form of the pores. So, the pores are primarily formed due to the limited kinetic energy of the particles at the time of impingement, and this may be due to the smaller, means very small mass of the particle or the limited particle velocity at the time of the impingement. So, velocity of the powder particle is crucial, especially with regard to the pores, and further if the particles are impinging with the limited kinetic energy, then the bonding between the coating material, that is the splat and the substrate, or splat to splat bonding will be limited. So, there are two aspects like the coating substrate bonding or the bonding between the splats, splat to splat bonding. So, if the kinetic energy of the powder particles or the semi melted or the melted particles is very limited, then there can be the bonding issues apart from the formation of the pores. These bonding issues can occur between the coating and the substrate or the splat to splat bonding. So, in that case there will be tendency for separation, removal or delamination of the coating material from the substrate, or the removal or the peeling off or the delamination of one layer of the coating material from the another layer. So, the cohesive strength under such conditions will be limited, and that is why it is important that the particle is having the enough kinetic energy, means enough the particle velocity at the time of the impingement, which of course is influenced by the kind of process used for the thermal spraying, significantly. So, about that we will be talking a little later. So, it is important that the powders either in the thermally softened condition or in the molten condition or the semi molten condition should have the enough kinetic energy. At the same time, it should get the minimum time of exposure at a higher temperature during the deposition process. So, the flight or the movement of the powder particles through the heat source should be for the shorter period, and in this regard the spacing that is called standoff distance, that the source of the nozzle and the workpiece surface or the substrate surface distance has to be optimized, not too very short, not too very long. If the nozzle to the substrate distance is very less, then these particles will not be able to attain much higher velocity, and that will be leading to the number of defects in form of force and the limited bond strength. But if the distance is too much, then the particle velocity may also get reduced, and the stay of the powder particles or in the molten state or semi molten state at a higher temperature will be longer, and that will be leading to the formation of the inclusions as well as thermal degradation tendency of the constituents in the powder particles will also be increased. So, the velocity of the powder particles is very crucial with regard to the high temperature exposure period, as well as the chances for the interaction of the feedstock material with the gases which are present all around. So, now we will see what are the possibilities due to the too high temperature exposure for longer period. What kind of the damages can take place? So, the damages which are observed primarily in form of the increased interaction between the gases around the molten or semi molten feedstock material particles. Another damage is the thermal decomposition of some of the constituents like tungsten carbide, chromium carbide. These particles start getting decomposed and damaged with regard to the properties and composition. So, we do not get the properties which we are expecting on the surface of the coating. So, unnecessary too high temperature exposure for longer period of the feedstock material during the thermal spraying has to be avoided in order to reduce the chances for the thermal damage of the feedstock material and during the thermal spraying process. So, now to summarize, now what we will see that the particle velocity, if the particle velocity is increased, then we will be finding the increased bonding between the coating and substrate. This will be reducing the chances for the porosity, and this will be in general increasing the quality and the soundness of the coating. Increase in powder particle velocity will also be reducing the chances of the gas material interactions, which otherwise leads to the formation of the inclusions. So, now we will see the kind of the powder particles velocities which are realized. This diagram basically shows the kind of the defects which can be formed during the thermal spraying. Like this is the substrate. On the substrate, when impingement of the molten or semi-molten particles takes place, splats are formed and then they get deposited on the surface of the coating. There is a possibility that due to the larger size of the particles or due to the high refractoriness characteristic of the feedstock material, there may be unmelted particles also. And when the particle velocity is limited, kinetic energy is limited at the time of impingement, there can be unfilled gaps between the splats and substrates or between the splats themselves. So, this will be leading to the formation of the pores, and when the particles do not impinge with the sufficient kinetic energy, there can be limited bonding between the splats themselves also, and when the gases interact with the material of the feedstock, then it will be leading to the formation of the inclusion. So, these are various kind of the issues and the defects. There are three common problems which are encountered during the common problems in case of the thermal spread coatings. Now, we will just see that the kind of the heating which takes place and the kind of particle velocity which is achieved during the three most commonly used thermal spray processes, namely flame spraying, plasma spraying and high velocity oxy-fuel spray. So, the coating material which is used for flame spraying can be in form of powder or wire. For plasma spray, mostly it is powder, but it can also be in form of wires, and for high velocity oxy-fuel spray, mostly it is in form of powders, and the heat is generated basically from the generated by the combustion of the oxygen and the fuel, which can be like propane or the acetylene, and in case of the heat, in case of the plasma spray, is achieved through the plasma, and in case of the high velocity oxy-fuel spray, again it is oxygen and fuel gas mixture which is burned for generating the heat. The temperature which is produced is in the range of like 3000 3500, while in case of the plasma spray it is 10,000 to 15,000 degree centigrade, while in case of the HPF spray process, again it is in line with the flame spray like 3000 to 3500. The gas velocities in case of the flame spray is limited below 300 meter per second. For plasma spray it is 400 to 500 meter per second, while in case of the HVF process it is 1500 to 2000. This is important because it will be dictating the particle velocity at the time of spray. Now we will coming to the two important and very crucial characteristics associated with these processes: particle temperature governing the thermal damage of the feedstock material. In case of the flame spray, the temperature is limited like 1500 to 2200 degree centigrade, while in case of the plasma spray, the particle temperature is around 2700 to 3500 degree centigrade. So, there is more tendency for thermal damage, while in case of the HVF spray, again it is 1500 to 2200 degree centigrade. But since the particle velocity is too high, so there may not be any melting in case of the HVF process, or the melting may be very limited at the surface only. So, the semi molten state may be realized in case of the HVF process. Particle velocity is very limited or very less in case of the flame spraying, and that is why it offers the very larger porosities and limited bond strength, while the particle velocity is in the range of 100 to the 200 meter per second in case of the plasma spray, and it is very high 600 to 800 meter per second in case of the HVF spray process. Since the particle temperature and particle velocities differ significantly with the process of the thermal spray, and that is why we get the different characteristics in the thermal spread coatings with regard to the porosity, bond strength and the quality of the coating materials which is achieved. Now, I will summarize this presentation. In this presentation, basically I have talked about the basic principle of the thermal spread process and what are the crucial parameters associated with the thermal spread process which govern the quality of the thermal spread coatings. Thank you for your attention.